Welcome to the Mr. McMurdo Math Maniacs Math Network. I, of course, am Damon McMurdo, and I'm here to help my students with some multiplying of fractions. They have had an assignment. The question is as follows. What has a bottom at the top? Some of you already have it done. What does it say?
What has a bottom at the top?
Yes, but what's the answer?
A leg.
A leg. Good. A leg.
I finished.
Here's the leg, and at the top you have a bottom.
Oh, it's a leg.
I'm just saying. All right, so let's look at. I'm going to do. Well, first I'm going to tell you number 21 is the answer is 1/6. So if you haven't done 21, the answer is 1/6.
I got one.
It's 1/6.
I simplified it too much.
Let's look at 17 because we had a lot of questions on this type of problem. We have 4/9 times 16 times 3/8. Hey, come on and say hi. Oh, to me or to them?
Both. I got you.
What's up, man? Thank you.
Quick apex break.
You're missing the gray.
Well, you know,
It's not gray.
just wait a couple of years. It'll get there.
Good to see you guys.
Apex is here.
All right, so
Yeah. Yay!
when we multiply with fractions,
You said let's look at number 16.
well, I don't know, is that 16?
21.
17? 17. I already told you number 21 is 1/6. Just because I was being nice. All right, when we look at this problem, Tucker, what do you think the issue most people had with this problem was? Multiplying it by a whole number. You can make any whole number into a fraction that quickly. All you really have to do is put it over 1. Because as I've said, fraction is a division problem. So 16 divided by 1 is 16. So that's the same value. This problem is actually saying 4 divided by 9. 3 divided by 8. And yes, you can do that because you can put the decimal point in the zeros. So then it's just simply multiplying your numerator straight across and then your denominator straight across. Some of you are like, I don't know what to do if it has 3 fractions because 3 fractions are way so hard. Well, if you did just 3 whole numbers, you would do it the same thing and you guys wouldn't say it was hard. And since we're just doing numerators times numerators times numerator, and that's going to be your new numerator. New numerator. So let's figure out, do we know what 4 times 3 is? 12. And since I can do multiplication in any order, I can do them in any order. I'm going to do 4 times 3, which I know is 12, times, I only have 16 left. Some of you still struggle with 2-digit multiplication.
192.
So 6 times 2 is 12, carry the 1. 6 times 1 is 6, plus 1 is 7. So 6 times 12 is 72. Y'all should know that. You should know. Now the 1 is in the tens place. So we're actually multiplying 12 times 10. So 12 times 10 is obviously 120. We add our 2 products together, and we should get 2 in the ones place, 9 in the tens place. So we should get 192 as our new numerator. 192 as our new numerator.
Okay. I did it.
And then our denominator, my mouth is still asleep, multiply 9 times 8 is 72 times 1, so just 72. And this is what type of fraction? Improper fraction. And how do we change an improper fraction?
By dividing it.
Dividing the denominator into the numerator.
Mr. McMurdo, I have a question.
Okay, I'll answer it later. Divide. What's your question?
Alright, you know how the effects guy came in here?
Okay, but that has nothing to do with what we're
in
doing.
the description below, can't you put a link to the videos?
I don't know.
Alright.
72. I'll say 192 divided by 72. Sorry.
No, just conferencing with the teacher.
Okay. 192 divided by 72. Well, let me ask an important question. Janelle,
Yeah.
is 72 going to go into 1? Nope.
Nah.
Janelle, is 72 going to go into 19? Nope.
It's going to be no.
Is 72 going to go into 192? Yes. I am going to have one digit. Did you lose yours? That'd be horrible. I'm going to have one digit as my quotient. Now you can count by sevens. So if I round 72 to 70, I count 70, then 140.
Then
What's 7 times 3? 21. So 210. So 210 is too big. So it's probably going to be 2. So then 72 times 2, which you really should be able to do that in your head, because 2 times 2 is 4. So it should be, what, 144?
Yes.
Okay. Then I do some simple subtraction. Oh, I can't do 2 ones. Subtract 4 ones.
Yeah.
Because if I only have 2 ones, I can't take away 4 of these. Unless I break my ones in half, and that would hurt. Which, I wonder if I'd get any time off work for that. Because it could be worth it.
Try it.
Alright, so I'm going to have to take 1 10 away from this and make that 9 and 8. So instead of 9 tens, I have 8 tens. And so I'm taking 1 10 away. 1 10 equals 10 ones. So I add 10 ones to my 2 ones. And I get 12 ones. 12 ones. Subtract 4 ones equals
8
ones. 8 tens. Subtract 4 tens equals 4 tens. Now 48, I don't have any more numbers, so 48 is going to be my remainder. That seems like a big remainder. Is that going to be okay? Maybe it's either a yes or no. Why not?
Because it's huge.
Because it's huge, Tristan?
It's bigger than the number.
It's bigger than the number.
No, it's not. The number.
No. It has to be smaller than my divisor. So is 48 smaller than 72? So this is going to be fine. 2 remainder 48. Which is going to equal my whole number. My whole number is a 2, because that's my quotient. My remainder is my numerator, so that's 48. My denominator is the same denominator, so that makes it 72. If you look, that answer is not there, which is sad.
Wait, are we doing the orange test cards?
Okay, no, you've been, so don't talk. Because you haven't been paying attention, so don't talk.
We're doing one of the
Alright, so we need to simplify. We have 2 and 48 over 72. We need to simplify our fraction. I can tell right away. Now I'm going to simplify in steps. You don't have to do it all at once. I'm going to simplify in steps. So what is an easy number I can divide by? They're both even, so Rhett?
2.
Since they're both even, I can divide them both by 2. I only simplify the fraction. I do not, and I mean do not, simplify the whole number. Because if I had $2 and then 50 pennies, I'm going to simplify the 50 pennies into 2 quarters, so 50 cents. I'm not going to simplify the dollars, so I don't simplify my whole numbers. So I can divide, they're both even. I can divide both my numerator and denominator by 2. And Tucker, what is 48 divided by 2? 24. So now I have 2 and 24. Let's see. Who should I call on to tell me what 71 or 72 divided by 2 is?
I'm dying, don't call
Good. Let's call on Ashley.
Okay.
72 divided by 2. Shh. I have faith. You gotta have faith.
Faith.
You gotta have faith. Baby. How much? 63.
Baby.
No, 36. Thank you. 36. So now I have 2 and 24. 36. Hannah, is that as small as it can go? It is not there. So my guess is it is not as small as it can go. So Hannah, are they both even numbers? 36 and 24.
Yes.
Even numbers in a 0, 2, 4, 6, or 8. So yes, they are. So that means I can divide it by what, Hannah? 2. Every even number can be divided by 2 evenly. So now I'm going to divide by 2. Hannah, what is 24 divided by 2? What's half of 24? Shh. If you need to work it out, work it out. Shh. 12. So now I have 2 and 12. What is 36 divided by 2, Heron? 18. So now I have 2 and 12 eighteenths. 2 and 12 eighteenths. Can I divide it by 2 again?
Yes.
Yes, they're both even. Any other number I can divide it by that might make it?
3. 6.
I can divide it by 2 and 3, which means I can divide it by 6. If it's divisible by both 2 and 3, it's also divisible by 6. If I remember my divisibility rules. Of course, some of you just don't even look at your divisibility rules ever again. So if I divide these both by 6, what is 12 divided by 6, Antonio?
12 divided by 6?
Yes. 2.
Wait.
And Antonio, what is 18 divided by 6? 3. So now I've done all this work, and of course I told you you had to show all your work. So my final answer is 2 and 2/3. So for that answer, for that problem, you should have the answer 2 and 2/3. 2 and 2/3.
I see paper.
Yes, sir.
You could have done it in easier way.
I could have done it by 12 here.
Yeah, when it was 48 and 72, you could have done it by 12.
I could have done it by 12. Well, if you look, 2 times 2 is 4. 4 times 6, I could have also done it by 24. No, not by 24, by 12. By 24 as well?
Yeah.
Oh yeah, I could have done it by 24 as well. I could have done it by 24 as well. But I'm not making you figure all that out. If it just asks you to simplify, then simply simplify. If it asks you what the greatest common factor is, then you're going to have to actually do the math to find the greatest common factor. Let's do an orange problem. Number 5. 7/10. Subtract 1/2 on the orange cards. Number 5 on the orange card. Number 5 on the orange card. So I'm doing number 5 on the orange card. Yes, I am. So if you haven't turned in your orange cards, you may want to write this down. I'm just saying. On the orange cards, let me tell you first of all, they write them horizontally. My advice to you, as I've said before, you should write them vertically. Mr. Fant, have you done the orange cards yet? You might want to write these down because I'm doing number 5 for you. Well, yeah, but I'm showing work when I do number 5. Do you have a question? Oh, you're going to help me? All right, Hira. Can I subtract 1/2 from 7/10 the way it's currently written? No, why not? You don't know? Good. I have to have a least common denominator. I have to have the least common denominator in order to add and subtract fractions. They must, and I mean must, have the same denominator, or it can't be done. Hira, what are my two denominators? 10 and 2. I want to list the multiples of 10 and 2 till I find the first one they have in common. Peyton, what is your question? Never mind is her question. So I need to find them. Yes, ma'am. Oh, okay. The under found it, but here's helping me. So Hira, which one should I start with? The 2. I'd like to start with the smaller one to see if the larger one is a multiple of the smaller one. So I need to find if 10 is a multiple of 2. So 2, 4, 6, 8, 10. So my least common denominator is 10. Some of you, I noticed when you were doing this yesterday, were absolutely insane. And you just subtracted 2 minus 10 is 8, 7 minus 1 is 6, which doesn't make any sense.
Wait, but can't you do that though?
No. You have to find a common denominator.
Wait, and how come you can do that in adding?
No, you can't do it in adding.
Oh, only in multiplying?
Yep. So now I need to change both these fractions so that they have a denominator of 10 without changing the values. So that they have a denominator of 10 without changing the values. Which means I need to multiply by a fraction that equals 1. Because if I multiply something by 1, I don't change the value. Well, 7/10 already has a denominator of 10. So if I just multiply that by 1 over 1, that's going to equal 1. And so 7/10 times 1 over 1 equals 7/10. Hira, I can't multiply this by 1 over 1. What do I need to multiply it by? 5/5. 5/5. 5/5 equals 1. So I'm not changing the value. So just like here, if I have 5/5, it's the same as saying 1. So I'm not changing the value of 1/2. I'm just writing it in a different way so that my denominators are the same. So 1 times 5 is 5.
Oh.
It's Davis. Woo! Fire over there today. So Hira, is this an addition or subtraction problem, Hira? Subtraction. I always like to bring my sign over so I can keep track of what kind of problem it is. Hira,
It's subtraction?
7/10 subtract 5/10 is what? 2/10. Now, what many of you did it yesterday? You just left it as 2/10. But we cannot, or your mean teacher will mark it wrong. So you need to convert, or you need to change it so that it has a common denominator. So I need to take 2/10 is what I have, and I need to simplify 2/10. Hira, what am I going to simplify by? By 2. If I do the greatest common factor for 2 and 10, the only factors of 2 are 1 and 2 because it's prime. The factors of 10 are 1 and 10, 2 and 5. The greatest one they have in common is 2. So I use that and I simplify this fraction. And here a 2 divided by 2 is?
1.
And 10 divided by 2 is? 5. So 1/5. If you didn't have 1/5 as your answer for number 5 on the orange cards, and you turned it in early, and I graded it and allowed you to do it again, then you can do it again and put 1/5 this next time.
Wait,
9.
is it 2/5 though?
No. If I have 2/10 and 1/5 are equal, because I divided, 2 divided by 2 is 1. And I can show you and prove it that 2/10 is exactly 1/5. Half of 1/5 is 1/10. So you can do it that way. Now I know this is confusing for those watching at home because we're changing back and forth between adding and subtracting and multiplying, but this is really for the benefit of the students that I teach because I love you all.
No!
So let's jump back and do one from the A-leg assignment.
16.
All right, 16. Let's do 7/6 times 2/5 times 30.
Thank you. I got that. Which number is that?
I don't know.
16.
The one I just said it was for those that were listening. 7/6 times 2/5 times 30. 7/6 times 2/5 times 30. Now I had some freaking out yesterday. The people that were freaking out were because 7/6 was improper and thought they had to change it. Well, you do not have to change it.
Okay,
I don't know who you are. You don't change. You do not change the improper fraction to a mixed number until you get to the answer.
this right here.
Okay. We change the whole number to a fraction by putting it over 1. Then we just multiply numerator times numerator times numerator. I'm going to multiply 7 times 2, which is 14. And I'm going to multiply 14 times 30, which just really means I just have to move that 0 down. because that's what's going to be in my ones place. Because 0 times 4 is 0, 0 times 1 is 0. So it's just going to be a 0 in the ones place. And then I do 3 times 4, which is 12. Carry my 1. 3 times 1 plus 1 is 4.
420.
So my numerator should be 420. It should be. My denominator is pretty easy. 6 times 5 times 1 is 30. And that is an improper fraction. Since it is an improper fraction, I can change that improper fraction to a mixed number by dividing. Janelle. Now they both have a 0 in the ones place, so I really can take those off and just make it 42 divided by 3. Because if you look, 30 goes into 42, so I'm going to have a 2-digit number. 3 goes into 42. It's going to give me a 2-digit number. It's going to give me the same 2-digit number. Riley, you're writing this down? Awesome sauce. Now, as I noticed many of you were like trying to figure out what 2-digit number it was, do it one step at a time. You put one number in the quotient at a time. So Bea, 3 goes into 4 how many times? 1. And 1 times 3 is what, Bea? And 3 from 4 is what, Bea? 1. Then I bring down my 2. Bea, 3 goes into 12 how many times? 4. And 3 times 4 is what, Bea? 12. And take 12 from 12, you get 0. Oh my word! There's no remainder. So I should have 14 and 0 thirds? No, if you don't have any parts of a fraction, your answer is just going to be 14. So for that problem, your answer is simply 14. Yes, ma'am. In a moment. For that problem, your answer is simply 14. I don't know, the one I just did.
No, whichever one that is.
Hira.
Number 20.
What?
If you do 76 times 2, that'll be 14 30. And then if you just put a 30 there, it would be 14.
Yeah. So let's look at, the three of you make noise and laugh at everything anybody says. Oh my gosh, there was a horrible car wreck and 78 people died. Ha 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 ha! You laugh at things that aren't even funny.
Yeah. Or what?
Let's look at one of the green cards.
Wait, there's green?
That I changed to orange.
Wait, which number?
The number that is 1/2 plus 1/6.
I don't know what it is.
I don't remember.
Yes, you do.
1. Number 1.
Oh, it's number 1.
Oh, yes,
1.
1/2 plus 1/6. Najane, can I add those together like they currently are? Say no. Say no.
It's 4 6.
No, good. Because they do not have the same denominator.
Are you going orange cards?
So I need to find the least common denominator for 2 and 6. Yes. Peyton. Never mind. So, on problem number 1 for the orange cards, which is what I'm doing right now. On problem number 1 for the orange cards, which I'm doing right now, I need to find the least common denominator. And if I take my smaller of my two denominators and see if the larger of my two denominators is a multiple of it, which 6 is a multiple of 2, this tells me I need to change them so that they're both over 6. They both have a denominator of 6. And this one, my second add-in, already has a denominator of 6. So it's just going to stay 1/6. My second one needs to be changed without changing the value so that it has a denominator of 6. So I have right now 1/2, and I need to figure out how many 6ths are in 1/2, equivalent to 1/2. So Najane, 2 times what would give me 6?
I don't know.
Well, figure it out then.
Two times what would give me 6?
That's what I said, yes. Count by 2s.
No. I don't need 6.
Okay, then what's my answer?
3.
3. Since I don't want to change the value, I have to multiply by 3 over 3, because that's 1. And 1/2 does equal 3/6. This is an addition problem.
Wait, but if you got 3/6, but wouldn't you convert that into 1/2 and then?
Yes, but I need to have a common denominator before I can add. I can't add these without having a common denominator. So I'm changing it from 1/2 to 3/6, because I can add 3/6 plus 1/6 because they have the same denominator. Najane, what's 3/6 plus 1/6?
Huh? Nothing funny.
What is 3/6 plus 1/6, Najane? 4/6. Okay, 3/6 plus 1/6 is 4/6. However, Najane, they're both even numbers, so that means I can simplify it by what? What goes into every even number? 2. 2 goes into every even number. So I can divide both the numerator and the denominator by 2. So Najane, 4 divided by 2 is?
8. 12.
No, 4 divided by 2.
Oh. Oh.
How many groups of 2 can you make if you have 4?
2.
2. And Najane, 6 divided by 2.
3.
3. So 4/6 is the same value as 2/3. 4/6 is the same value as 2/3. So 2/3 would be your final answer for number 1 on the orange cards. Number 1 on the orange cards. So really there are only 8 questions on the orange cards. I've done 2 of them for you. Probably in my second class, if they can act like they have some sort of sense, I will do 2 of them. In my third class, I will do 2 of them. And after school, I will do 2 of them. So that would be a total of all of them, 8 of them. So really, if you want to watch the videos, by tomorrow you should easily be able to have all 8 of them done correctly. Therefore, before the time of giving presents under the tree where Santa comes, that is called Christmas. Before that, you'll have a good grade in the grade book, which will make your parents happy. Boom! Shakalaka. Peace out. God bless. Love y'all. Do something kind today.